Hello, and sorry we are late. We had some minor issue with the screen. Well, welcome to this session. I'm Florian, and I will be talking about modern business intelligence using Azure in Platform as a Service. First, few words about me. I'm a SQL Server MVP from France. I'm a consultant. I do consulting works for a company called Selenza. We are a small company with 50 consultants, 10 MVPs, a regional director lately. So we really focus on high-level expertise on the tools. And another specificity that we have is that we are focused on agile development methods. We are almost all, whether Scrum Master or Product Owner, or involved in the new application lifecycle method. Okay. Let's dive in. So, just a few things I wanted to say about title. First, I want to say that by modern, I mean that I want to do things in I want to say, okay, we have new tools, we have new capabilities, we have Azure, we have the cloud, and maybe we can see business intelligence in a new way and try to do things starting from a clean slate. So, of course, we're going to reproduce the error of the past. That's obvious, but just to try to address the problem with a new point of view. We want to have an approach, seeing things like a platform and not a project. The main difference being you don't want to work on one-shot projects. You want to invest in a platform and be able to reuse it to serve different customers, internal customers or external customers. Even if you're inside your IT department, you want to be able to build a product, a platform that you are going to be able to reuse. And Azure, I think you know what it is. And Platform as a Service, we'll talk a little more about that. But why do try to do things another way than the way we usually do? Because life is short, and what I like to do is do things once, deploy them, put them in production, and then improve on them. And what I would really like, if each improvement that I made would be able to impact my previous deployments. I build once, I put them to production, and when I improve on them, then it will impact all my customers. That's what I would like. And in business intelligence, it can be quite difficult. Because right now we only have two main things that help us. First, of course, Scrum and Kanban and Lean IT and all these methodologies that can help us address our projects in new ways. But once again, they focused on projects and project management and your relationships with the rest of the company, your business users and everything. And it won't help you actually, in your day-to-day life as a developer, as a BI developer, to build things in a better way. It's a good starting ground, but not enough. Another thing that can help us is the BI markup language, which is a great tool to automatically generate integration services package and solutions. I'm guessing if you're here and not in the other room where they're talking about BIML, is whether you already know well about it or you don't know about it at all. If that's the second case, I really encourage you to check it. It's really a beautiful product. But it's kind of focused on the back office stuff. It's focused on the ETL part and the database part. It's not yet all-encompassing, and you can build your whole business intelligence solution with it. But it's really good initiative. And why so little? We can ask the question, why in business intelligence we don't have tools that are better to do these kind of things? We are constrained by two main things. The first is we are pulling data from other systems that don't belong to us. So we are interconnected, and it can be a problem because you build things, they change things, they work your things, and it's not really good. You have dependencies that are often not, I think there's many of us that have started the BI project, just taken a look at the underlying database and there's a whole LTP source application, and just start querying on it and building ETLs. And suddenly, you have the developers that call you and say, okay, what are you doing with my database? And, oh yeah, I've forgotten to tell you about it. You introduce dependencies in the systems and it's not really good. And third, and the second one is, in my opinion, the most important, is the inertia due to data volume. Because You can say, okay, in Scrum, I'm going to do 2-week sprints. So I'm going to deliver value every 2 weeks to my customers. But what if the value is added by adding, changing the dimensionality of a fact table? I want to add a dimension to a fact table, a new way to slice my data. If my fact table has 100 million rows, I'm going to have a problem. And even just talking about it, it's, you imagine that big challenge, and it's going to be, you're going to drag, and it's going to be really difficult to do that kind of things. So we have these constraints that we have to deal with. But what if we could do anything? What if we could, just forget about that and say, okay, how would we like to do these kind of things? So I'm in my shop, being a consultancy firm or just internal IT, and I have my R&D team that works on a new BI product, not a project, a product. And I'm quite proud about it, and I push it to my first customer, okay? So it's delivered into its IT, and it exposes API that can be used by the different application from his IT to interconnect with me. So using this interface, I can communicate with his IT modules, pull data, and do some things. That's good. And if my R&D push another version of this same module, I can just push it, and that as long as it preserves the API contract, you can just, you can railroad things down to your different customers, and it will just work. And you can also serve this same module to another customer and have a better return of our investment, and serve multiple customers with your same BI modules using a different API to connect to a different system. So maybe the orange one is a point-of-sale system, and maybe the blue one is a CRM system. You still have the same kind of BI being done there, but you can use it at different customer sites. And these two ideas, in fact, that's not science fiction. That's the current state of the art in application lifecycle management for software development. It's two quite simple ideas. It's software containers and application platforms. If you've heard the words Heroku or Docker, that's concepts that we are talking about. You just build your code, and you can push it on different platforms, and it just works. Just interface with API and with different things, and it just works. And that's the second idea, the microservices, which is just a service-oriented architecture done right, meaning instead of having big monolithic applications, you slice them in little parts that communicate between them. That way, if you build, I don't know, something that generates PDF, a PDF rendering engine, you're able to reuse it at a different point in your IT, and it's just not embedded in this big application and not reusable elsewhere. Okay. And where could we put all that? Of course, it's in the cloud, because it's the single point that I share, the single IT domain that I share with my different customers and with my software vendor. Okay, so easy access for everywhere. It's a common ground that I can share with everyone. It can handle multi-tenancy, so I can have multiple customers and have a better return of investment, and it can scale quite well. And why would we do it in platform as a service? Because, we're in cloud, but we could use VMs, in the cloud to do that. It's a nice little graph, not by me, you have the source there, that explains the differences between the different typologies of deployments. My work as a consultant is building BI stuff. What I like is thinking about dimensionalities, granularities, playing with the Kimball approach, go and gather requirements and build a good dimensional model, and that's what's fun. So what I want to do is play on the compute, calculate things, play on the storage, store my data, but I don't want to install software. I don't want to manage backups and anything. It's not interesting to me. That's where we make most of our money, but that's not what is interesting. So, so I want to do platform as a service stuff and package that and push that to my customer as software as a service. Software as a service meaning I'm able to bill my customers maybe $5 per user and per month, and give them access to my stuff. And everything works, and everyone is happy. And by the way, if you've seen the keynote yesterday, That's kind of what Microsoft is pushing on us as a business model. So you have to think about that. Because right now, Microsoft is getting quite good at PaaS approach. And they are eating our work, because when you do stuff in a SQL database, you don't manage backup, you don't manage anything like that, you don't manage patching. So that's your business going away if you do that, if you do infrastructure. So you have to think about how to change your business model to adapt to that. And to do what? An example, end goal that we could aim at is, for example, Twitter, which deals with 5 million tweets per day, just in kind of volumetry. That's just mind-blowing. And on that, they managed to do search. They managed to do dashboarding. They managed to do a lot of different things. And one of them being a new product that they launched lately that is called Answers. Which is when you develop a mobile application, you can copy and paste their code snippet into your code, and it generates telemetry. When a user does something, it sends a log. When the app crashes, it does a log. When the application is downloaded from the store, it sends telemetry data. And with that, they are able to do in real time true analytics, in my sense, because okay, you have the sums of things or the count of things. Okay, you can see how they can do that. But they calculate quite complicated KPIs on that. And on the fly, they are able to do machine learning. They are able to do segmentation, so clustering, and to detect anomaly or to detect that crash are too strong or things like that, adapted to your context. So if they are able to do things like that, maybe we can ask them a thing or two on how they do that, so that we can maybe get some lessons from them. And that's the first approach that was defined by Nathan Mars, not working at Twitter at the time, but then his company was bought by Twitter, and they applied it to this product. It's a Lambda Architecture. Maybe some of you have already heard this name. It's been quite heavily used by marketing departments. But we don't care about marketing. We care about designing systems. And the main idea that is interesting in that is that you have your data incoming from somewhere. And what you do is implement two separate layers. So the top one is the batch layer, okay? Not real time. You're doing your typical ETL stuff. And the bottom one is a speed layer. You're doing streaming stuff. And you're calculating things on the fly. And what is an interesting idea is to say, okay, I want to expose that data to my user transparently. And that's an important point. You're doing a true Lambda architecture if you expose the data to your user transparently coming from the two layers. If you want something to help you understand this principle, think about an analysis services cube, where you have the same user group with one partition in rollup that do direct query to the underlying database, and a partition in mollup that is processed every night. Your user access to this cube via pivot table, and with the same pivot table can see data coming from the two partitions, and it's transparent for him. He doesn't see the difference, okay? And every night, data is transferred, processed, and reset. So that's an important point of the Lambda architecture. The two other important points are the immutable append-only set of raw data, and we are going to see that, and that everywhere you're seeing views, okay? You're not saying tables. The word is well selected, it's views. So what is an immutable append-only raw data? If you have to take only one thing from this talk, it's that this guy published a talk on YouTube turning the database inside out, and it's just mind-blowing. It really, for me, it was almost a deep experience. So I really highly recommend you to check it. So what does he say? He say when you deal with a shopping cart, you have a customer ID, product ID, and a quantity. And when you want to change that, what you usually do in our world, you just push an update on it and say, okay, this customer, this product, the new quantity is 3. Okay, all right. But you have two ways of seeing that. The first one is just what they call a mutation, okay? And the difference between an immutable fact is, the immutable fact is you have a timestamp. So you know when the mutation was applied, okay? This one, you can take it out of context and understand something. The first one, you have lost a piece of information. You don't know when it applies. And it's kind of complicated to regenerate intermediary position from that. And when you think about it, yeah, that's what we do in an ETL. When you access the underlying database and you don't have a transaction table, just regenerate intermediary position from stocks at the end of the day. But you're losing information because maybe there were 3 transactions in the day. So depending on the time granularity where you do your export, you may lose information. If we could always access to that kind of information, the immutable facts, then maybe it would be far better for us. And the other one is views as layers. What they mean by that is if we have these immutable events stored in a single place that we will call the master datasets, and they are just logs, in fact, operational logs, then we can just build intermediary views to go to my different use case. What's important is when you are in this approach, you are on a schema on read approach. Okay, that's another buzzword, but schema on read meaning the priority is given to the one who is writing to the database. If it changes formats, no problem, because it's just pushing logs one after the other. The one who is having difficulty is the one who is reading from this dataset. That's us doing business intelligence. And one of our main problem, our main issues, as I was saying earlier, is that we don't want to have data inertia. We don't want to have a pool of data that prevent us from moving quickly. So the only way we can do that is by building intermediary views, by using views instead of tables to do that kind of things. So that's the idea. But when you reach high volumetry and you want to query that, you're going to have a performance issue. Meaning yes, we are using views, but we want to use materialized views. Meaning we want them to touch the disk, we want them to be stored, but we don't want to manage that ourselves. We don't want to use an ETL to do that. We want to use the exact concept of SQL Server being the materialized views. You define your view, you add a word on top saying it's materialized when you create it, and then it's stored on disk, okay? And when the underlying data changes, the views is updated, but it's done transparently for us, the developer. It's done by the middleware, it's done by SQL Server. So that's maybe a good thing to do. And noting that the same thing that Hadoop does, when you have different, you start from the first log files and you build pig queries, statements, or hive queries. Each time you chain one query after the other, it goes to disk, each time. So, but this is not important, it's not your point of reference. Your point of reference is the master dataset. And we can imagine that in a BI context and say, okay, we have 2 applications that are pushing data toward me. I have a procurement application, I have a point of sales, and I have CRMs. And each one push immutable events to me. They are stored in a master record, and on that I'm going to build some views. A dimension view and fact views. First layer of dimension, second layer of facts. And when you think about it, with command table expressions and with windowed function, right now we are able to simulate almost any kind of operations that we usually do with an ETL. You can generate surrogate keys, you can handle SCDs in certain conditions, you can do a lot of stuff. Again, not talking about performance issue, but just the feasibility of things. Yes, we could do that sort of things. So, that's the point. Maybe we can go in that direction and see how we can do that. But if you looked at this schema, there's no more notion of a batch layer and a streaming layer. We are not in that context anymore. And maybe that's the point of it. Maybe we can go further because it's quite hard to maintain this kind of architectures because your jobs, you've developed them in 2 languages, in Storm, in your real-time processing engine, and in your batch processing engine, to do the same kind of information to present them for your user as a single view. And it can be quite complicated. But if the stream processing system was fast enough. Maybe we can use it for everything, you know? Just push your records in it and query it and see if you can directly build your dimensional model on it. That's what these guys have been doing. So that's Jay Krebs, questioning the Lambda architecture at the top. Is a guy who is building Kafka stream processing system. So these guys are not just people coming from nowhere. They are active contributor to the Hadoop ecosystem, and their systems are deployed in production at LinkedIn, at Yahoo, at Twitter, and every other big name in the internet domain. And it works. They've done these kinds of things. So maybe we can try to replicate that kind of architectures in Azure, you know, and try to do the same thing. So yeah, we would have immutable append-only raw data store. We could use Event Hub. Event Hub is a concentrator. It's something that you can push your logs. Yes? No?
You can finish and then come back with a question.
Yeah, okay. Event Hub is a concentrator where you can push all your logs and just let him deal with the retention and with performance and the scalability and everything. It just handles that magically for you. After that, you build your different views, your different queries, trying to accessing this Event Hub, and you materialize them in an Azure SQL database. Maybe we can try to build something like that. You have a question?
Yes, you talked about multi-tenancy in the beginning.
Yeah.
Is that part of what you're talking about here? You've seen it as a multi-tenant platform.
Yeah.
One platform serving multiple customers.
Yeah, it's the end goal. Okay, that's what we're aiming for. What I will show right now, okay, it's early stages, so we'll keep it in mind, but it has to be, every independent part is able to handle multi-tenancy. Now you have to think it through and through, and security and everything, and that's kind of where it all fell off, but you know, it's at the end of the talk in theory. Okay, so that's what I'm going to try to show you. I'm gonna use a simple .NET application to push via API calls immutable logs. That's going to be stored in my Event Hub. Then I'm going to access them through Stream Analytics and push them to an Azure SQL database and see how we can query it with Power BI. Okay? The business case is by Microsoft. It's a program manager from the Stream Analytics products that has given it to partners so that we can train ourselves and do some stuff with it. It's available for download, so if you want it, there's the link in the presentation. I'm sorry, I have big ears and it keeps just falling off. So we are dealing with toll stations on a highway, cars going through, paying. Okay, everything is quite right. I'm receiving a data stream of, at this time, this license plate and this car go through. It weighs that much and everything, going through that toll. And on the other part, I have a registration database that want to flag when we have people going through that have specific attributes like is he a criminal, the car is stolen, or something like that. Okay. So let's see what we can do. First, I have to go see my application that will generate my events. Okay. So this is the exact same application that is provided by Microsoft. Okay, so you can download it. It's exact same things. And first thing it says is go and specify a service bus connection in the app config. Okay, I'm going to the app config and see that it's waiting for something. So I'll just go to Azure. Okay. That's funny because Scott Klein from Microsoft was demoing something earlier, and his portal was quite faster than mine. I don't know, and he's from Microsoft, so maybe there's something going on. I don't, So I'm going in the service bus area and say, okay, I want a new service bus because Event Hub are hosted into service bus. It's like that. SQL. Okay, I'm going to put it not too far away with this subscription. I'm doing messaging in standard. Okay. And it will create it. So this is a namespace, an environment in which I will create an event hub. Okay, here it is. I want to build an event hub. Okay, because I really respect the good practices, I will call it the same thing. Oh no, I didn't create it in the Western Europe? Yeah? Uh-huh. Yes, it was not, I was too fast for him. SQLRally. Okay, here it is. Okay, created an event hub, quite simple. And what I want is the information to connect to it. Okay, it says me there's other things to do. Create a policy to access it. Okay, I'm going to say I'm going to go for full because once again it's a good practice to do things like that. Okay, it's done. It's done. It's nice. And now what I want is my connection information. Here it is. It's copied. I go into my application and I paste it here. Okay, save my app config and run my program. It will launch in console mode and say, okay, just start sending my information in real time. You know, the car's going. Okay, that's nice. Usually I get these issues when I have connectivity issues, so 5 minutes ago it was working just fine. You know how it is. You know how it is. Okay, I may have been too quick there. Yeah, it should be good. Nothing's changed, so that's cool. Okay, fun. Yeah. Yeah, that's a good one. Oh, that's cool. No, nothing that failing just at the start of your demonstration. It's always good stuff. Put you in a good condition to continue. Let's try to take the other event hub. Maybe I created it wrong. Maybe that's what I did wrong. Go there. Take this one. Yes, of course. It couldn't be working. Okay, now it's working, but not sending that information to the good one. I've missed a step. I'm sorry about that. What? Yeah, it should work. Thank you. Okay, so I guess we're going to use this one. It doesn't bother you. So same thing. I created a service bus in it, an event hub, and I call it entry. So right now I'm pushing data to it. But it's not really visual, so I will check that I'm in fact sending data to it. here I have another little application. It's also available on the MSDN to check if you're really sending data to your event hub. What you have to do is, fun. Taking your So this one connects to the event hub and try to pull data from it. And that's this way we can check that there is indeed data going through. And yes, there is data going through, okay? If it's stabilized, because now it's taking, yeah, that's the real rhythm, okay? Before that, it was taking everything that was stored inside the event hub. And I don't know if you can see, but it's toll ID, entry time, license plate, state. That's the data I was showing you in the PowerPoint. Okay, good. So I'm going to stop that last one and let the process just send data to it. And where I want to go is in a database. That's what I was telling you. And this database is in Azure, okay? It's a SQL database, Azure SQL database. Okay, this is really due to connection issue. Because it's a really simple app, and each time it loses too much packets, it just resets the connection, and I'll have to just send it again. So I'm sorry, but it's going to be with us during the whole demonstration. And in my database, I created some tables and some views, date dimension, time dimension, registration dimension, the one with which one is a criminal, which one is not. And I also created a car model dimension. Okay, if I just look at it, yeah, it's not a good database. Everything's going according to plan. Okay, just put some data in it, days of 2015, time, registration, and different make and models. And I have a fact table that I want to populate with the data coming from the stream. And I'm going to do that using an Azure Stream Analytics job. So this time I'm going there. Okay, where are you? There. Okay, and I'm great. Yeah. I hope no one is epileptic in the room, because it could be a problem. So I'm going to start a new job. And this is where I'm going to create my views. And say, okay, SQL. Okay. And with this, what I'm going to do is say, okay, take that stream of data, that's my new immutable raw data append only master data set, and transforms it so that I can publish to my star schema. I have my first inputs, which is a data stream coming from an event hub. I'm going to call it entry stream. It's from the same subscription. Yeah, thank you very much. I was just saying, okay, I may have a problem here. Okay, and okay. Yeah, of course, why not? And the other things I need is, of course, my lookup tables, because when I build a star schema, at some time I need to do lookups to go and find my surrogate keys. Right now, one of the limitations of Azure Stream Analytics is you can only get reference data from blob files, so CSV files. That's kind of an issue, because your dimensions are in Azure SQL database. So yeah, so we'll deal with that. And they are here. I have two CSV files. So I need to call them ref license. It's from the same subscription. It's from this one. It's from toll data. Okay, and its name is not now, please. Registration.csv. Okay. Okay. So that's the first one. And I get, yeah. And I need another one doing the, you've guessed it. Each time I'm going to use this query as my view. And each time I define an input in my stream analytics job, I just call it, it's become a table in my query. So I need to match the name, of course, with my query. Okay. Yeah, of course. Okay, I have my three input data feed, and now I will just input my SQL query, my view that will do the transformation that I expect. So here, it's come from entry stream, the stream of data that's coming from the toll application. From that, I get the ID of the toll. Then I do two lookups disguised to go and seek the surrogate keys for the registration of the model. I do some calculation to get my keys for my time dimension and date dimension, and I had one as a passage count. So I save that, and I will add an output to a SQL database. This one. And the fact table. Okay. Of course, no surprise. Okay, everything is set up. Let's just launch it. And first thing the job asks when I launched it is, when do you want the job to happen? Because it's been 10, 15 minutes that I've launched the job generating data, and maybe I want to take that data and make it through Go My Stream. So it is asking me just that. And I'm going to say, yes, I want you to start 5 minutes ago, so that you can process the past. Interesting point for us doing business intelligence, because if I develop a new version of that view, I need to be able to reprocess things from the past. That's where I cross my finger and hope that everything goes according to plan. And if it does, I should see lines coming into my fact table from my stream. What I have to check is this one. Yeah, starting, so I have to wait. And another difference between what we usually do in business intelligence is, I'm sure that you've already had the problems that you were saying to yourself, I really would like this data6 package, this ETL job, to run in continue and just, check what is coming on in the table and process as it goes through. But that's not the way it's orientated, because it's batch orientated. So you can do that. You can simulate that with some change data capture and some things, but it's not the way it works. Here we are in a streaming approach. So my jobs are online. When they're online, they just stay there, wait for data to come in, and they just process things. That's how it works. It's processing. I have no error message, so it also takes 1 or 2 minutes to initialize. So right now, I'm just not panicking yet. I have an error message. Don't see it. Yeah, okay, here it is. It starts coming in. 64 rows. That's all. Okay, here they are. Okay, continually coming in into my table. And right now, I have a dimensional model, a star schema with dimension and a fact table. And they are online. And when something happens in my application, it just runs around the log file, it goes through the streaming application, and it goes into my fact table. Okay? I think that's quite nice. And we can, yeah, well, when you don't have issues with your... The application works well, by the way, so if you download it, it shouldn't happen. It's just because I'm demoing that I have an issue. And what you can do with that now is consume that. So you can go in Power BI, a new designer, and just go and get them. The only problem we have with this one now is we don't have all the features, okay? So you can, go get new source from Azure SQL database, but I've already registered the database. I can put it from there. And say, okay, I want my dimension and my fact table. Okay, just load them. Yes, maybe my database is not powerful enough, so I can just, go there and say, okay, go into standard, just level up a little, save. And it just became more powerful. So that's what you would expect from a demo perspective. Is just everything just well, it's not going to happen. You won't see the difference. Just to show off that I do that. Well, it's quite long now. Well, of course I'm dumb because it's there. But since there's a small downtime when you scale up. So if you do it right when you're querying it, it can be a dumb thing to do. And there's, of course, relationship between my different fact table and dimension, and I let Power BI discover them. And here we are. Can say, okay, by make, of course, this serial key doesn't make any sense. I want my passage count by make. Okay, that's cool. I want my passage count per... Okay, if I just manage to click in that, by time. Okay, that's cool. And you see that I've played with this event hub already. I've prepared this session, despite what it looks like. And there you have all the, when we started it, we reprocessed the past. So that's when we catched up with, the whole application. And maybe I won't start it anymore. And there I think that you have your service interruption each time the application crashes and I don't relaunch it. You see it? And we can do different things, and we can say, okay, maybe per model I want. Can do that? No, can't do that. I want also the passage count, but as some kind of graphic, and say, okay, if I only take the Ford, it will, and it will filter everything. So that's quite nice. And each time I press refresh, my star schema is live. So each time I press refresh, everything is going to be refreshed, and I'm going to see the new state of things. So that's quite good. Take your 20 seconds. Oh, it's better. I'm saying not being very nice with them. Okay, so that's nice. You can do that. It's plugged directly, and it's live, As the data is coming in, and in 15, 20 minutes, we are able to build this kind of real-time analytics that we weren't able to do before. So that's quite nice. But there are some places where the abstraction just break. So that's what we saw, okay? Logs, pushed, event hub, stream analytics, database, and I pull. What I really need to have a full picture of things, I would need to first have I cannot consider my event hub as my master dataset because it is flushed every 7 days. It has a maximum period of 7 days. That means that in it, I can go to the past, but only 7 days in the past. So it can be an inconvenience for us BI guys. So I have to write these logs somewhere. Be it as blob storage if it's a CSV, or maybe a document DB if it's JSON. Just pull them in there, in their original format. And if I need to reload the past, I just put them back into the event web through my stream analytics process and into the SQL database. Just truncate the database and get everything back. And another thing I couldn't play with because I'm a European is Power BI API, where you can push data directly from Azure SQL database. It just each time there is a new line, it is pushed to your database and your Power BI, and you just see the graph moving in front of you. So that could be quite nice also. But what I would really like to do is build a true conforming dimension service, because right now my dimensions are living in CSVs on blob storage. That's not very dynamic. And if I have a dimension where I get information from the stream, from the data source is pulling a new customer, so I get to add this customer to my dimension. Right now, I cannot do that with this architecture. What I would like to have is some kind of being able from the T-SQL to call an API and send it a business key, maybe my SCD type 2 fields, and say, give me a surrogate key in exchange. And that is what I will use. Not possible at the moment. And of course, this service will be able to interface with my master data management and expose dimension tables directly into my SQL database. Right now, that doesn't exist. And it's a problem with the managed approach. I just said, okay, platform as a service is quite good because you just take what you can, you use it. In 15 minutes, we've built this kind of things that before would have taken multiple months to build. Yes, if the features that you need are in the product. If they are not, and they are not, you cannot do it. The retaining capability of the Event Hub is an issue. It's quite honestly, it's a bad thing to say because you can send a huge amount of data to that thing and it will keep 7 days of it. It's just mind-blowing in terms of capacity because you can send millions of events per second. It takes this kind of charge. It doesn't fear it. And I'm here to say, okay, it's an issue. So I'm not really fair with the system. But for us, it's a real issue. And I have to implement a mechanism that deal with that. But in my dream, infinite retention of data in the Event Hub would be just great. And everything that we talk about is just a theory, because right now you can see, I think you can see a specific use case and say, okay, I have a use case where I could use that, but you could not think about replacing your current ETL strategies, data warehouse and cube by this kind of system. But that's what the guys at Twitter and LinkedIn are doing right now. So maybe we have to think about that and see how we can implement that. And it's a theory that it's quite alive. I've put some link for you to check. A lot of reference. Some of them are only 1 week old, and they are really defining. So it's really active. It's happening right now. So if you want to jump on the wagon, you can do it, and you can do it yourself because you can download the TOL application, no problem. Visual Studio now have a community edition that is free. So even if you are used to only have beads or SSDT, and you can do it with the community edition that is free. And of course, Azure always has free trials, so you can play with that. And if you need help, we are always here from the PaaS to help you. I can, and your local communities can too. So there it is. Maybe some of you have questions about that? Or you're just, saying he's just crazy, this guy? That's, I wouldn't. Well, thank you very much for your attention. Thank you.